Good evening, sir. Good evening to one and all. This is Meena. I am from ECB section. Bearing my roll number is 23401 at 474. Today, my topic is noise in AM, amplitude modulation, DSP, and SSP receivers. How different modulation schemes respond to noise. Introduction to noise in modulation. Noise is an unwanted disturbance that affects signal quality. Different modulation schemes have varying levels of susceptibility to noise. Understanding noise behavior is crucial for optimizing communication systems. Overview of modulation schemes. Amplitude modulation, double sideband and single sideband modulation are common methods. Each scheme encodes information differently, impacting noise performance. The choice of modulation affects the trade-offs between bandwidth power and noise resilience. Characteristics of amplitude modulation. Amplitude modulation signals are characterized by their varying amplitude to convey information. Noise affects the amplitude of the signal, leads to distortion and loss of clarity. Amplitude modulation is particularly susceptible to noise, especially in low signal to noise ratio environments of amplitude modulation. Noise impacts on AM receivers, amplitude receivers. The presence of noise can significantly degrade the quality of the received signal. This degradation often results in a phenomenon known as fading, where signal strength are fluctuates. Amplitude modulated receivers are a higher SNR to minor clear communication compared to other schemes. Signal power has y-axis and time as the x-axis. Characteristics of double sideband modulation. Double sideband modulation transmit information using both upper and lower sidebands. Like amplitude modulation, double sideband is also vulnerable to noise, impacting amplitude variations. However, DSP does not offer the same level of efficiency as SSP in terms of power and bandwidth. Noise impact on DSP receivers. DSP system exhibits noise effects similar to AM due to their amplitude based information encoding. The impact of noise can lead to reduced intelligence and increased distortion. Enhanced filtering techniques can help mitigate some noise effects in DSP. Where figure of merits for DSP modulation. SNR by output by SNRC k square k into k square by 1 plus k square a into p. P denotes the average power of message signal. M of t is the Ka is the amplitude sensitivity of amplitude modulator. Characteristics of single sideband modulation. Single sideband modulation transmits only one sideband, which makes it more efficiency in bandwidth usage. SSP is less affected by noise compared to AM amplitude modulation and DSP due to its reduced amplitude variations. The elimination of one sideband helps improve the signal to noise ratio efficiently. Noise impact on SSP receivers. SSP receivers exhibits better noise performance leading to clear reception in noisy environments. The demodulation process in SSP is more complex, which can introduce its own noise elements. SSP single sideband is the single sideband's efficiency allows for longer range communication with less power, which is beneficially in noisy conditions. Comparing noise resilience. Amplitude modulation is the least resilient to noise, requiring highest power for clear signals. DSP offers moderate resilience but still suffers from noise induced distortion. SSP stands out for the superior noise performance, make it deal for long distance communication. Conclusion and future directions to Understanding the noise behavior in modulation schemes is essential for designing robust communication system. Future advancements may focus on improving noise resilience across all modulation methods. All methods. Continued research into adaptive techniques can help enhance performance in noisy environments. Thank you, sir.